and then we use version control system such as GitHub or Bitbucket to keep the track of our software changes. Whenever we do any changes in our software, we commit those changes to cloud repository of Git or any version control system, because we have to keep the changes and we need to learn how our project is evolving day by day. uh, Version control systems are very essential to keep the track of changes, why particular changes happened, and whom changed particular system or any code base. So it is very essential to code review and having the accountability of code base, because uh, multiple developers will work on particular project. So we need to have track of changes, which developer is doing what and how they are changing the code, whether they are making correct addition to our code base or not. So to keep track of all those changes, we need to use version control systems. So in current era, now it is very essential to use version control systems, because without version control systems it is difficult to keep the track of project evolution, and if any error occurs or any mistake happen in production environment, then it is no developer will take the responsibility of that error. So by using version control systems, there is always track of each and every changes, and uh, why particular change is made, who made that change, and at what time that change is made. In fact, if we want to reverse those changes, we can take that previous copy of our version, our software's version. So it is really a helpful tool, and one must learn how to use such version control systems, and one should use it on a daily basis. So first of all, we will see what is version control system. So by definition, you can see a version control system is a software tool that tracks and manages changes to files over time, allowing user to revert to previous versions, collaborate effectively, and maintain a complete history of modifications. By creating a detailed record of every change, version control system tools protect projects from errors and offer robust support for teamwork in software development and beyond. Some examples of version control systems are Git, Mercurial, and Subversion. Subversion is a very legacy system where it is a centralized version control system is done. There is present. So if you see some functions of version control systems, so here they have already mentioned version tracking, means it records every modification made to files, creating a detailed history of changes, including the author, timestamp, and description of the change. Means it mention why particular changes happened, who made those changes, at what time that changes happened, and with every change there will be one comment, means explaining why particular changes happen, what are the different functionalities that have been changed, and all such details that is required for any new developer or any other team member to know about. So writing complete message while changing particular code base is very important. Writing very clear and communicative message, so that any person, if he read your message, he should understand what changes you have done as a developer, because your message should be self-sufficient, and one should not need to reach to you to learn about that changes. So you should write very proper, clean, and very self-sufficient message that should talk about itself only. You do not need to clarify or elaborate those changes. So try to write very clear and neat comment while you do any changes to code basis. Then after version tracking, we use version control system for reversion. See, if a mistake is made or a previous state is desired, means by mistake you do some error, or by mistake you make some changes and you want previous version of the software to work with, then you can easily turn back the clock and revert to any earlier version of a file, any earlier version of the file. Means you can go back whatever version you want, and you can get it in your system and you can work on it. Okay, so third is collaboration. See, we nowadays we don't work in a silos, we work in a collaboration. We will have lot of developers in our team, testers will be there, business analyst will be there, and other people like administrator, IT support guys will be there. Means there will be different kind of roles in our team. So project manager will be there. So we have to work in a collaboration. So version control system facilitates that teamwork by providing a central repository and workflows that help teams work together on the same project without conflicts, even when making simultaneous edits. See, version control system allows simultaneous work, so it speed up the development process, and each and every developer or every team member will work on separate functionality. So simultaneous development will happen, and it will increase the speed of software delivery. So it will definitely enhance the code quality also, because each and every person is working on different software functionality. So it will definitely enhance the speed of the software delivery and product delivery. And by working in collaboration, it is always possible to create have conflict. Means when 2 or 3 people will merge their code with our central code base, then there can be any conflicts also. But version control systems tackle those conflicts very properly. When multiple users modify the same part of file, a version control system can help identify and resolve these merged conflicts to prevent chaos and ensure everyone is using the correct updated versions. So version control will take care of each and every merge request of code, and it will definitely take care of every developer, and it will make sure that every developer is having updated copy of the project. Next, it will have project history. It provides a complete audit trail showing who made a change and when they made it and why, which is invaluable for debugging and understanding project evolution. See, for code reviews and for accountability of the particular changes, there should be history of each and every change, and there should be trail of each and every change, why particular change is made, who made that change, at what time that change is made, and whether it was required or not. So to make code review and having accountability of particular change, having project history is very important. So version control system solves that problem very properly. It saves each and every history and trail of each and every change. So it is really beneficial for tracking those changes and history of the project and how our project is evolving day by day. Now we will talk about how it works, the way version control systems are working nowadays. So repository will be there, a version control system stores all project files and their revision history in a centralized or distributed repository. Here it mentioned centralized, which is nothing but SVN is a centralized version control system, where it will save all the code base at one centralized system, and it will every day or every time it will distribute updated version of the software. Means every developer will check out code every day. Means it will take checkout means it will take that copy of the updated project in his machine. Okay, and then he will work on that copy, and at the end of the day or after changing whatever he want to change, he will commit those changes to he will save those changes to central repository, and then those changes will be reflected to each and every developer's copy from central repository. So SVN's long form is subversion. It is developed by Apache, and we can say that it can be useful for larger code bases, because each and every developer will not have whole project in his system. Whole project and its history will be saved in central server only. So it is best for big project where larger files are there of revision history. And there another it is a centralized version control system, and we have Git, which is distributed version control system. Distributed version control system means each and every developer will have his own copy of the project and its history of revisions and changes and all those things. So so it becomes really best system for someone or for projects which are not really big and they don't have that much bigger history of changes. But nowadays it is everyone is using Git, and Git for version control system as a version control system. So there will be repository where all the changes will be tracked, then committing changes. When a developer makes changes, they commit them to the repository, creating a new version entry in the project's history. Then after commit, updating or syncing of the project will be happen. Means developer can update or sync their local working copy. Update or sync their local working copy with the latest version from the repository, ensuring everyone is aligned. So these are the few operations those are done by version control system. Now we will see how we will work with Git, and how we will work with GitHub. Okay, Git is a see Git is a Git and GitHub. See Git is a version control system. It is a distributed version control system. Distributed version control system. We should increase its font. Okay, is a distributed version control system which tracks all the changes made in projects in local machine, whereas GitHub is a cloud based repository for Git projects, or Git repositories. Means GitHub will host or store all the Git repositories in an online mode, that is in cloud. Okay, space should be okay. Same Bitbucket is also there, which is also doing same thing. It is a cloud based repository or cloud based storage for Git repositories. Same. So we will learn how to work with GitHub and Bitbucket. We will learn about both the things, but first we will need to see how we will create particular repository and how will we go ahead with each and every changes, and what type of branches we will create. So first we will have main branch. Okay, so that we will have main or master branch. Master branch. Previously we used to call it a master branch, but in IT industry there is a means there was a debate that why to call it a master and why not. Means we should not we should have proper naming conventions also. We should not call someone master and someone slave. So they made it changes to it, and nowadays lot of people use main as a main branch. Okay, then we will have integration branch. Integration branch. See, it is nothing but a copy of your project. These branches are not any rocket science. These are nothing but copies of your project, and depending on its completion, project will be moved from one location to one copy to another copy. You will learn about it. Just wait for some minute. These are feature branches. What feature branches? Feature, FEE, feature. This is nothing but a feature branch. And then we will have developers. Now we will see how it will work. Your feature branch code will go to integration branch. Okay, this code will go to integration branch, and if we want we can take it from this also. So this is the flow. Now we will have local Git repositories. There will be some folders. If we let us consider this. Here it is the developer's machine. Okay, and he will commit or no, 1 minute. Sorry. See, first we will go ahead with D1, developer 1, developer 2, and developer 3. So there will be local repository, and this is the ID of developer. So any change will be reflected to local repository, and this local repository will track each and every changes made in any project in that ID. Okay, and after we have to use some commands to make all those changes. Okay, this will like that here we will do local repository. It is nothing but local repository, local repo. Local repo. Now whenever any code changes happen, it will reflect in local repository when you do add and commit, but those changes will not be reflected in cloud. In here feature branch, you have to do other operations like see when you do any changes, then you have to use add and commit. By using those command, by adding and committing those changes made in project ID or your project code base will reflect in local repository, but that change is still in local repository. It is not there in your cloud. So you have to use another command, that is push. Here now your local repository changes in local repository will reflect in your feature branch. So first of all, learn about feature branch. Why feature branch is important? For each and every feature we will create a separate feature branch, and it will not be we will not have one branch for lot of same feature branch for lot of features. Each and every developer will be assigned with one particular feature to develop, and he will create one feature branch for that particular feature, and everyone will work simultaneously on each and every features. So feature branch is in cloud only. Okay, and we do not create project structure in each and every developer's machine. One developer, senior most developer, will discuss everything about project, and he will create all the project structure in his own local machine, his machine. He will discuss each with each and every team member, and with proper decision making he will decide which dependencies we need, what are the different features we want, what type of structure we should go ahead with, what type of packages we should take, and what type of technology we should use. All the decisions will happen, and then he will create particular project in his system, and then he will commit those changes to cloud. Okay, it's cloud repository, and then each and every developer will create feature branch, and he will work on particular feature. So this is the flow. And after feature branch, if we want to commit those changes from feature branch to integration branch, then you have to raise pull request to commit changes in feature branch to integration branch. Here merging of all the coding will happen. Okay, means feature or functionality from developer 1, functionality from developer 2, functionality from developer 3 will be merged in integration branch. Okay, and then and only then it will be confirmed by your team member or team leader. He will approve those merge requests, and he will suggest any changes to your feature branch, and without any confirmation you cannot directly commit into integration branch, or no one will approve that change that thing to you also. So always remember, you have to test your code properly. You can means at feature branch, every level there will be particular testing. Especially you will have your development environment, and there will be testing for each and every environment. For example, for feature branch, you will have here you will have unit testing. Here you will develop you will code your you will test your code in AWS develop environment. In integration branch, you will test your code in QA AWS QA environment. Means here testers will test your code. There will be UAT testing also. So after QA and testing QA, there will be your code will be moved to main branch. Okay, and at the end here this is nothing but a main branch code will be sent into production ready code, which is nothing but a production ready code, and we will deploy that code into production environment. So after here it will be production environment. So this is a proper flow of our project. Means at feature branch level, AWS developer will test our code and in a development environment. After integrating that code, we will test that code in a QA environment, and when we move that code into master branch, we will test that code in a production environment, and finally we will put that code into production environment, deploy that code, and that is nothing but a functional software is ready for working. In between this, there will UAT testing will also happen. See, remember, UAT testing will also happen in between. UAT testing means nothing but a user acceptance testing. So remember this flow. Now we will see one particular example and how to create repository with that example in GitHub and Bitbucket. Let's start our project in Spring Tool. First we will see into Bitbucket, then we will move to GitHub. We will create new project and we will see how it will function. Okay, new Spring starter project. Okay, we will see Git demo or Bitbucket, or we will see addition. We will see calculator project. Okay, calculator demo app. We will select Java 17 and packaging should be jar. It should be Maven. Build tool should be Maven, and then example.package demo. Okay, this is fine. Okay. Okay, now we will choose dependency. Web dependency is needed. Spring Web. Okay. We will just take simple project. Okay, we do not need very detailed project. We just need to demonstrate how to work with GitHub and Bitbucket. So we will call it a finish. Okay, let us see what will happen. Okay, this project structure is very proper. Let us see pom.xml is also there, and we will have our project. This is our main function app, main app. Okay, From this class our execution will start, but we will do one create controller, which is nothing but control. It should have controller package, and we will name it as a addition. Okay, addition controller. It will just return addition of two numbers, or we will see it will just return some string value. Okay, so we will take one function. Okay, public string hello return welcome to Spring Boot. Welcome to Spring Boot. Here we need to call it as a REST controller because it is having functionality, and this method should be get mapping. Okay, get mapping to map our request, map our endpoint. We use such type of annotations. Annotation starts with @ and get mapping is nothing but for get request, HTTP get request. It will return some data to browser or any client. So let us see now. We will go to GitHub. Okay, now see guys, we will create one repository here, and that repository we will name it as a calculator demo, and we will place today's date. Okay, which is nothing but 2409. Okay, so to identify it very properly, description we will simple calculator for demonstration on 24 of September 2025. Okay, we will keep every setting as it is, and we will create this repository. Okay, if you want you can add a readme file also, and we will keep it as a private, so no need to have it public repository, because we do not need to have public repository for our client. We should keep it in private only. So we will create this repository. Now we just need to commit that code, whatever we have written here, to our remote repository. So first of all, we should commit this code into our local repository. And how can we do that? Just remember one thing. You can do it through your browser, your IDE also. So whatever you can do, you can just right click on your project. This is our project. Okay guys, remember this is our project, and we just need to go to this option, that is team option. Okay, just go here and share project. Remember this, you just need to do one thing. You just need to share project, and you just need to create one repository. This is nothing but a repository 3, but we will name it as a calculator demo 24/9. Okay, and branch is, it should be master branch. Okay, or it should be main branch, no problem. Now this will be created on local repository. This is nothing but a local repository. Okay, first of all it will create local repository. Now you will see how this, can you see, see, just remember this. Can you see this question mark here? It is showing that we have created local repository, Git repository for this project, but you are yet to commit all those changes. So first of all, whatever we will do, we will commit all these changes, and to commit all these changes, we will use our guys, here we need to look after this git staging, where now whenever can you see, this is how you need to open the git perspective. Previously I don't have git perspective on my IDE, so I went here, Windows, perspective, and then open perspective, other, and then I selected from this git. Okay, then this window appeared. Which window? You can see this window, git staging, git tree, all these things, but we do not need other type, we just need git staging. Okay, so at git staging you can see unstaged changes. When all these new files are whatever you can see question mark, all it is stating that all these files are new files, and we just need to add or remove whatever operation you want, and we should perform that operation and commit those changes to our local repository. So I will add all those changes, then it will go to stage changes. Previously it was unstaged changes, and which is nothing but a add stage, means we added those changes in stage changes, it becomes stage changes. Now we will perform first commit of project, first commit. Okay, I will just use simple commit, first commit, and then I will commit. Here two options are there, commit and push, and commit only. So here this is my Sandeep course and email ID, this is my username and email ID from GitHub repository. Okay, so by using this I can directly commit my code to my local as well as remote repository if I use this button. But for teaching or you should get complete scenario, that's why I am not committing and pushing, I will just commit. So now these changes are committed to our local repository. Now we have to commit these changes to our remote repository. First we will check whether these changes are reflecting in remote repository or not. See, this is our remote repository and there is no changes, so it is completely blank. Okay, we don't have any changes right now. Now we will change our repository and we will push those changes to our remote repository. Now we will go here at project title, and then we will go to team. Here we need to change push main branch. Okay, this option, push main branch, if we place this, it will ask you URI. URI is nothing but your path, and you will go to your repository and you will copy this path. See, press here at code and then copy this copied path. Okay, and just come here and paste it. You can see each and every detail. Host is github.com, repository path will be there, my username, and then our repository name will be there. Now see here, user and password is coming. Here user is nothing but me, that is my username of GitHub, whereas password is nothing but a API key. Okay, which is produced for every month for each and every user, and I have to use that API key. which is private key. So it will automatically, once you use it, your ID will store it in it with itself, and every time whenever you try to commit push to local remote repository, it will definitely it by default it will use that key. So we will go ahead. When pulling, we will merge it. Okay, correct. Force override branch in remote if it exists and has diverged. Yes, correct. We need to push, make that changes, and now we will finally push those changes. Now our changes are will be reflected in remote repository also. See, right now there is no changes, but when I refresh this, you can see all those changes. See guys, you can see calculator demo app and all those changes. For example, we will go to our main class also, controller, addition controller. See, welcome to Spring Boot and all those things. Now I will change one line, or I will add 1 or 2 line with our functionality, and we will see whether that line is reflecting to our previous remote location or not. So I will use sysout. It is not good practice to use sysout, so we can use sysout, or we can use other functionality also if we want, but particularly I personally feel that I should use I will, whatever I will do sysout welcome to Spring Boot and Java, and another statement should be hello world with Java. We will add simple 2 statements, and we will see whether these changes will reflect on our remote code base or not. Right now these changes are not there, you can see it here. Okay, now we will commit those changes. Now same process will be repeated. Okay, we will go here. No need to go here also, you can just see it should automatically recognize. Okay, it is not recognizing. Just go here, team, and commit. Now whatever new changes happened, it will definitely come here. I haven't saved it. Okay, it should automatically commit here. Yes, whenever I save it, it automatically commit. You just need to check. See, I will add another line. Hello, how are you? Okay, how are you? Now if I don't save these changes here, it will not reflect here also, but if I save it, it will automatically reflect in that place. Now see, can you see 3 lines are there? So we should go back. Yes, correct. So we will commit these changes. We will add 1 commit, second commit, and this time we will commit and push. Okay, so it will save into our local repository and as well as our remote repository. Yes, now we will check whether it is reflected. We need to make it, we will need to reload this page, and see guys, these changes are reflected here. So this is how we should use our version control systems, and every time whenever we do any changes to our system, we should make it available to each and every developer. Okay, and in case of crash of system, or all any kind of error or any kind of tragedy, we need to have our code base on remote system, remote repository. So it is very good practice to always commit your code and push your code onto remote repository. So thank you guys. I wanted to discuss about Bitbucket also, but this becomes very lengthy video, and it will be difficult for you guys to watch it completely. So we will discuss it later, but right now thank you for your attention. Please go through it and tell me your feedback. Thank you guys.